Hey everyone, welcome back. Grade 7, I am so excited to jump into this with you today. As you gear up for your upcoming Python mini projects, I wanted to put together this explainer to help you avoid one of the most common, just hair-pulling frustrations in programming. Today, we're going full code detective. We're going to investigate a classic Python debugging mystery that traps, honestly, almost every new coder. So grab your magnifying glasses, because we have a mystery to solve. So picture this. You're working on your mini project, right? You assign a string to a variable, maybe it's some user input you really need to clean up. You run a super helpful string method on it, you hit print, and nothing. The string stubbornly looks exactly the same. No way, right? You check your code, you run it again, but your text just completely refuses to update. Why didn't your string change? Well, to solve this, we actually have to look at how we think about variables in the first place. The root of this whole mystery actually starts with a super common beginner myth. You know, when we first learn to code, it's really helpful to imagine variables as physical containers. We tend to picture them as little Tupperware boxes or buckets. You put a word inside the box, you close the lid, and when you run a command on that box, you just naturally assume the word inside gets directly modified, kind of like adding leftover pizza to a container. But here's the secret. In Python, that's not exactly how it works. Okay, let's really dive into this. We need to upgrade our mental model here. The common myth is that variables are boxes holding data. But the reality? Variables are actually a lot more like sticky name tags pointing to data that lives somewhere in the computer's memory. You don't put data inside a variable, you slap a variable name tag onto the data. And this distinction, it's absolutely crucial for our whole investigation, especially when we're dealing with text. All right, let's look at part 1, the evidence, where we investigate the Python 3.14.7 documentation. If you look in the official documentation under sequence types, you're going to find a really important computer science vocabulary word, immutable. Now, immutable simply means unable to be changed after it is created. It basically means it's set in stone, locked, totally permanent. And here is the absolute smoking gun pulled directly from the Python documentation. It reads, strings are immutable sequences of Unicode code points. There is also no mutable string type. Wow. Okay, so strings, which, remember, is just the programming term for text data, are completely 100% unwilling to change their minds once they're created in your computer's memory. You literally cannot modify a string in place. It's impossible. So moving on to part 2, the suspects. Let's look at the copycat string methods. Because wait a minute, if strings can never ever be changed, what about all those awesome built-in string methods we learned about? The ones you're supposed to use in your mini projects? Well, here we have some of the most popular ones, .upper, .replace, .strip, and .split. Now, I want you to listen super closely to the phrasing right out of the Python documentation here. Look at the description for .upper. It says, return a copy of the string. Look at .replace, return a copy. .strip, return a copy. You see the pattern? Because strings are immutable, these methods do not change your original string at all. They act exactly like a photocopier. They take the original, make the changes you ask for, and just hand you a brand new copy. Which brings us to part 3, the fix. Let's walk through a mini project worked example. So let's jump right into the lab and actually fix some broken code. Here is the exact setup you might use when trying to clean up some messy text. Step 1, we assign our variable. Let's say secret_code equals the string Python, but with a bunch of annoying spaces on the outside. Step 2, we call secret_code.strip to clean up those spaces. And step 3, we print it out. Now, if you do exactly this in your project, you're going to be pretty disappointed. And this completely illustrates why. If we check the output here, the original variable, secret_code, still has all those messy spaces. It is completely untouched because, say it with me, strings are immutable. Now, the .strip method actually did its job perfectly. It generated a beautiful, clean returned value of just Python with no spaces. But because we didn't actually do anything with that returned copy, Python just threw it away into the digital void. Poof, it's gone forever. So how on earth do we rescue that shiny new copy? Well, we use the real hero of our story, variable reassignment. Remember how we said variables are sticky name tags, right? Not boxes? To keep our changed string, we just need to take the secret_code name tag off the old messy string in memory and stick it directly onto the brand new clean copy that the method just handed back to us. Let's see how this actually builds our final code. Step 1 is exactly the same, but look at step 2. We don't just say secret_code.strip, we say secret_code equals secret_code.strip. So the absolutely crucial point is right here. By using that equal sign, we are taking our variable name tag and reassigning it to the result of the method. We are officially capturing our updated copy. Now, in step 3, when we print secret underscore, it outputs the beautiful, clean text we actually wanted all along.
All right, wrapping things up with part 4, your turn, the mini project challenge.
And there you have it, detectives. Mystery officially solved. Strings are immutable, methods return copies, and variable reassignment is exactly how we capture those copies. So I'll leave you with this final challenge to think about as you start programming this week. If you call a string method without reassigning the result, what exactly is happening behind the scenes in your code? And more importantly, how will you set up your own variables to ensure you correctly capture every single transformed string? Keep your name tags sticky, remember your strings are set in stone, and good luck building those bug-free mini projects. But, here's a final thought to keep you up at night. If Python is constantly making new copies of strings instead of just changing them, doesn't that waste a ton of computer memory? We'll crack that case next time.